Hi, thanks for watching my video. We're going to continue our discussion of the lateral area, the total area, and the volume of the different solids that we come across in geometry. I want to show you a brief review using a PowerPoint, and then I'll introduce some of the terms and different parts of a pyramid before introducing you to the formulas for pyramids. In a separate video, I'm going to conclude the PowerPoint where we'll introduce the different formulas associated with a cone, and finally with a hemisphere and a sphere. All right, thanks for watching.
Okay. As you recall, Chapter 12 was on lateral area, total area, and the volume of cylinders. The volume of solids. Well, we talked last week about prisms and cylinders because they're just so similar to each other. Prisms have two parallel bases that are polygons, and their lateral faces are parallelograms. Now, in our book, all the prisms that we're studying are called right prisms. Doesn't mean that the bases are right triangles. It just means that the lateral faces and the bases meet at 90 degrees. So in other words, they stand straight up. So prisms have two parallel polygon bases and rectangles as the lateral faces. The lateral area is just the perimeter of the base times the height of the prism. Not the height of the base. The total area is going to equal the lateral area plus 2 times the area of the base. These two last formulas should definitely be in your formula sheet.
Cylinders, like prisms, have two parallel circular bases. So cylinders have a very similar basis for the formula for lateral area and total area, that being the perimeter of the base times the height of the prism for lateral area, and lateral area plus 2 times the area of the base for the total area. But with cylinders, we can be more specific. Because it's a circular base, the perimeter of the base will be the circumference of the circle times the height of the prism in order to get the lateral area. So LA equals 2 pi RH, and total area equals the lateral area, 2 pi RH, plus the 2 times the area of the base. Since the base is a circle, that just becomes 2 pi r squared. That brings us to pyramids. Now this familiar shape has a lot of pieces that I'd like to make sure we're comfortable with before moving on to some of the formulas associated with pyramids. Let's take a look at just a diagram of a pyramid. You all recognize that up at the top is the vertex. I think we've come across that before. Opposite the vertex is the base. Now the base can be any shaped polygon, and typically in the pyramids that we look at, it'll be a regular polygon base. When it is regular, the base diagonals will intersect directly below the vertex. Now, the lateral faces, which are all triangles in a pyramid, meet at the lateral edge. So PA is a lateral edge, so is PB, PC, and PD. The lateral faces meet the base at the base edge. So AB is a base edge, BC, CD, and AD. All right, let's move on to some of the formulas. All right, the first formulas I want to talk about are the lateral area and the total area. Now, very similar to prisms and cylinders, we're going to find the lateral area by multiplying the perimeter of the base times the slant height. But with pyramids, we have this 1/2. And that comes from the fact that the lateral faces are all triangles. So just as the area of a triangle is 1/2 base times height, the lateral area is going to be 1/2 perimeter of the base times the slant height. Now the slant height is another part of the pyramid that we need to be familiar with. The slant height extends from the vertex to the base edge and forms a 90-degree angle with it. It is the height of one of the triangular faces. Now in regular based pyramids, this slant height will meet at the midpoint. So two very important qualities of the slant height are that it forms a 90-degree angle with the base edge, and in regular based pyramids, it bisects the base. All right, then let's take a look at another formula, and that being the volume. Now, the volume of a pyramid is 1/3 the area of the base times the altitude. Now, the altitude is not the slant height. The pyramid's altitude stretches through the middle of the pyramid, and it reaches from the vertex and forms a 90-degree angle with the base. For a regular polygon-based pyramid, that intersection will also be the intersection of the diagonals. All right, so quickly to review, the lateral area is 1/2 perimeter of the base times the slant height, but that's really for regular pyramids only, which is all our book deals with. And then the total area is the area of the base. I'm going to end this video here, and I'd like you to rewatch it, pause it as you need, but let's come in ready tomorrow to work with pyramids in the book.